Let's take a look at type 2 concentration. In type 2 concentrations, like I said, all of your quantities used to express the concentration are either mass or moles. So these are independent of temperature. So molality, note the difference there between in the spelling. Molality, that with the L, whereas the earlier one we talked about was molarity, is defined as moles of solute per kilogram of solvent. Okay, not solution, but solvent. Percent by mass is defined, or percent by weight is defined as gram solid over gram solution. So the mass of solid is a percentage of the total mass of the solution. So you can multiply that by 100%. Parts per million is basically the same thing as similar to percent by mass, basically the same thing, except that it is multiplied by 10 to the 6th. Okay, so it's a fraction, the amount of solid in the mass of the solid as a fraction of the total mass of the solution expressed as parts per million. Okay, 10 to the 6 is 1 million. So think of percentage as part per 100. So parts per million you multiply by 10 to the 6 instead of 100%. So if you want to put a unit here, you can say times 10 to the 6 ppm. Okay. 10 to the 6 parts per million, a million is 10 to the 6, so that's essentially a 1. So what you're doing is you're just expressing that fraction as a ppm rather than a percent. Parts per billion is the same thing, except that a billion is 10 to the 9, so you multiply by 10 to the 9. Now, you'll notice that you can also express parts per million as milligrams of solid per kilogram of solution. Why is that? A milligram is 10 to the negative 3 grams, and a kilogram is 10 to the 3rd gram. So that means that is equal to 1 over 10 to the 6, that ratio. Okay, so that's a part, 1 part out of a million. A milligram is 1/1,000,000th of a kilogram. Or you can also say that that's essentially micrograms of solute per gram of solution. Microgram is 10 to the negative 6 grams. Okay, so 1 part in a million. So 1 microgram would be 1/1,000,000th of a gram. And finally, mole fraction is just the ratio of the moles of whatever component you're interested in. Could be a solid, could be the solvent. Okay, divided by the total moles. So if ends of A, if you have a mixture of A, B, C, and so on, divide the number of moles of A by the total number of moles, that gives you the mole fraction of A. One thing to note about mole fractions is if you add up all the mole fractions for all the components of your mixture, those mole fractions should add up to 1. Okay? Here's a simple example. Suppose you have 18 grams of glucose, C6H12O6. You mix it with 200 grams of water. Let's calculate molality, percent by mass, ppm, ppb, and mole fractions. Let's start with the percent by mass, ppm, and ppb, though, because those are easy. All right, so let's start with percent by weight, or mass percent. That's grams of glucose. Doesn't have to be grams. You can make it kilograms as long as you're using the same unit for the mass, over grams of solution. So how many grams of glucose do we have? 18.0 grams. What's grams of solution? It's not 200. 200 is just the water. Okay, so you have to add the water and the glucose. That's the whole thing. So that's 218.0 grams. And multiply that by 100%. So that gives you 18 divided by 218.08256 times 100%. So this is 0.08257. 0.08257 times 100%. Okay, so number of sig figs here, 3 sig figs in the numerator, 4 in the denominator. That means you need to keep 3 sig figs, 0.0825. So that's going to be 0.0826 times 100%. That's going to be 8.26%. Okay. right? Let me just verify my numbers. 18 divided by 218 times 100, yeah, 8.26%. Okay. How do you get parts per million? Parts per million would be the same ratio, so 18.0 over 218 times 10 to the 6 parts per million. Okay, so that would be equal to, this is ppm of glucose. Okay, it's going to be equal to 0.0826 times 10 to the 6 parts per million. Okay, or that's going to be 8.2612, so that's times 10 to the 4th parts per million. Now, you'll notice this is a large number. We generally don't use parts per million when you have numbers this large. Okay, so it's not convenient. But the reason parts per million is defined is sometimes we have to deal with very, very low concentrations, and so if you get numbers like huge numbers like this, it's not a convenient unit to use. Parts per billion, same thing, except you multiply by 10 to the 9, so it's going to be 8.26 times 10 to the 7 parts per billion. Okay. How about molality? Let's do molality. Molality. Molality is defined as moles of solid, so in this case our solid is glucose, C6H12O6, divided by the kilograms of your solvent, which in this case is water. So let's calculate moles of glucose. If you know the mass, that's the mass of glucose, 18.0 grams. Okay. Basically, you divide it by the molar mass. What's the molar mass of glucose? C6, so that's 6 times 12.01, H12, so that's 12 times 1.008 grams per mole, O6, so that's going to be 16 times, molar mass of oxygen is 16. You did this, you should get 180.2, okay? So 180.2 grams per mole is the molar mass of glucose. Grams cancel out there. That gives you moles. Divided by kilograms of solvent. Our solvent is water, so that's 200 grams. Change that to kilograms would be 1 kilogram is equal to 1,000 grams, right? So that cancels it out. That gives you your unit in moles per kilogram. So let's do that. 18.0 divided by 180.2 divided by 200. I'm just going to divide that by 0.2, okay? And that should give me 0.499. Why did I divide by 0.2? This thing right here, 200 over 1,000, that's 0.2. So this is going to give me 0.4994. So 0.4994 moles per kilogram. Keep in mind, when we say moles per kilogram, what we really mean is moles of whatever the solid is per kilogram of solvent. Sig figs, you have 3 sig figs here, 4 sig figs, 4 sig figs, exact numbers, so your answer should have only 3 sig figs. So it's 0.499. So this solution we say is 0.499 molal, if you want to write it that way, okay? Or you can just abbreviate it, 0.499, and then little m is the abbreviation for molality. What about mole fractions? Let's calculate mole fractions. By definition, mole fraction is just the number of moles or whatever component you're interested in divided by the total number of moles. So mole fraction of glucose is just, oops, I'm sorry. Abbreviation for mole fraction is X. The symbol is X. So mole fraction of glucose is moles of glucose over moles total. So how do we solve for moles of glucose? We have 18.0 grams of glucose divided by 18.02 grams per mole. Okay, so you divide the mass by the molar mass. That gives you moles. And the total would be glucose and the water. So I already have the glucose right here, 18.0 grams over 18, oops, it should be 180.2, sorry. This is 180.2 grams per mole. Okay, and so 18.0 over 180.2 grams per mole. Cancels grams. Plus moles of water. So this is your glucose. This is glucose, moles of glucose. And you need moles of water over here. So how many moles of water do we have? We have 200 grams of water. So I need to change that to moles. So 200.0 grams. Molar mass of water, by now you should know it, it's 18.02 grams per mole. Okay. H is, you have 2 hydrogens, so 2 times 1.008. And 1 oxygen is 16.00, so that would give you 16 plus 2.016, 18.02 grams per mole is the molar mass of water. So let's add these all up. Let's calculate. We're going to get 18 over 180.2. At 0.09989. 0.9989. Okay. And the denominator is, your moles are just going to cancel out. Mole fraction is unitless. 0.09989 plus the water. 200 divided by 18.02, that gives you 11.099. Okay, so 11.099. Now you may be asking about sig figs here. All right, this is 3 sig figs. Okay, so we use at least 4 sig figs for our molar mass. We should keep 3 sig figs in our numerator, right? But we're going to keep that extra digit there just so we don't build up round-off errors, since that's an intermediate calculation. And then moles, the same thing down here, 3 sig figs, and then moles of water, 200.0. That's 4 sig figs, so 1, 2, 3, 4, and then we keep, again, we're just keeping that extra digit there for safety. Okay, so this gives us 0.09989 over, what's the sum of the two things in the denominator? 11.099 plus 0.09989, that's 11.1989. So obviously I have more sig figs in my numerator. My last sig fig here should be this one right here. And actually this one right here, right? Okay. This is my last sig fig. So I have 4 sig figs in the denominator. So this gives you 0.09989 divided by 11.1989. That gives you 0.003 sig figs, 00892. 3 sig figs, 00892. That's your mole fraction of glucose. How do you get the mole fraction of water? To get the mole fraction of water, it's just moles of water over moles total, right? So in this case, you're going to put 11.099 over 11.1989, or you can just say it's 1 minus 0.00892, okay? And that's